When installing a non-SDS optional standby generator with a whole house transfer, several factors need consideration, particularly regarding grounding and adherence to the National Electrical Code, or NEC. Let's examine the code requirements, best practices, and alternative solutions for a safe and compliant installation. NEC Section 250.24 B3 requires the grounded or neutral conductor to be bonded to the equipment grounding conductor at the service entrance. This bonding ensures a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protective devices. NEC Section 250.24 C3 further specifies that the equipment grounding conductor must be grounded at the service entrance. This requirement reinforces the importance of establishing a solid connection to earth, minimizing voltage potential and enhancing safety. NEC Section 408.33 mandates that a generator transfer switch be rated for service if it is used as a service disconnect. This is crucial because a service disconnect must be capable of interrupting the full available fault current at the service entrance. From a best practices perspective, the recommended approach involves moving the main bonding jumper, or MBJ, from the original combo service entrance to the new service disconnect. By relocating the MBJ, the grounding system is properly maintained and aligned with code requirements. This ensures that the neutral conductor is bonded to the equipment grounding conductor at the appropriate location, minimizing the risk of stray currents and voltage imbalances. If relocating the MBJ is not feasible, an alternative solution can be implemented. Firstly, install a new MBJ at the new service disconnect, connecting the grounded or neutral conductor, the equipment grounding conductor, and the enclosure. This establishes a new bonding point at the service disconnect, effectively replicating the function of the original MBJ. Secondly, connect the grounding conductors from the automatic transfer switch, or ATS, to the new MBJ at the service disconnect. This ensures that the ATS is properly grounded, providing a safe path for fault current to return to the source. Thirdly, seal the grounded, or neutral, service conductor lug in the original combo service entrance to prevent any possible parallel paths to ground. This is crucial to avoid circulating currents and voltage drops, which can compromise the performance of the grounding system. Regarding additional notes, it's essential to ensure that all enclosures are properly bonded and isolated to prevent parallel paths. This involves using bonding jumpers to connect metal enclosures and insulating them from other conductive surfaces. If the new service-rated enclosure is non-metallic, a grounding electrode conductor, or GEC, must be run from the new enclosure to the grounding electrode system. This provides a direct connection to earth, enhancing the effectiveness of the grounding system. The automatic transfer switch, or ATS, must be rated for service, as indicated in NEC Section 408.33. This means that the ATS must be capable of withstanding the full available fault current at the service entrance. Finally, it is recommended to consult with an electrician for guidance on this type of installation. A qualified electrician can assess the specific requirements of the installation and ensure that it is compliant with all applicable codes and regulations. When dealing with all-in-one panels, where the service disconnect, overcurrent protection, and distribution panel are combined in a single enclosure, specific considerations arise. These panels often have a riveted grounded service conductor lug, which is attached to the equipment grounding conductor, grounding electrode conductor, and neutral bus. In such cases, it's crucial to carefully evaluate the existing grounding system and determine the best approach for integrating the new service disconnect and automatic transfer switch. If the existing service entrance equipment is not service-rated, which is a common scenario with all-in-one panels, a new service-rated enclosure with an overcurrent protective device, or OCPD, disconnect must be installed. This new enclosure will serve as the service disconnect and provide overcurrent protection for the entire system. To maintain the integrity of the grounding system, several options are available. One approach is to extend the grounded, or neutral, service conductor from the existing combo bonded bus to the new disconnect neutral lugs, and then on to the automatic transfer switch, bonding again at the neutral lugs. This creates a continuous neutral path from the service entrance to the ATS, ensuring proper grounding throughout the system. Another approach involves moving the grounding electrode conductor and equipment grounding conductor to the new service disconnect. This effectively establishes a new grounding point at the service disconnect, providing a more direct path to ground. However, this approach may require modifications to the existing grounding system, which should be carefully evaluated by a qualified electrician. To prevent parallel paths, all enclosures should be isolated by polyvinyl chloride, or PVC, or other suitable insulating materials. This ensures that the only path for fault current is through the designated grounding conductors. In summary, installing a non-SDS optional standby generator with whole house transfer requires careful attention to grounding and compliance with the National Electrical Code. By following best practices and consulting with an electrician, a safe and reliable installation can be achieved. The following points should be taken into consideration during the design and installation process. Firstly, grounding is a critical aspect of electrical safety, and it's essential to ensure that the grounding system is properly designed and installed. Secondly, the National Electrical Code provides comprehensive guidelines for grounding and bonding electrical systems, and it's important to adhere to these guidelines. Thirdly, all-in-one panels present unique challenges for grounding, and it's crucial to carefully evaluate the existing grounding system and determine the best approach for integrating the new service disconnect and automatic transfer switch. Fourthly, preventing parallel paths is essential to ensure that the grounding system functions properly. Fifthly, consulting with an electrician is recommended to ensure that the installation is compliant with all applicable codes and regulations. Additional considerations for standby generator installations include load calculations. A load calculation must be performed to determine the appropriate size of the generator and transfer switch. This calculation should take into account all of the loads that will be powered by the generator, including lighting, appliances, and HVAC equipment. Overcurrent protection is another essential consideration. The generator and transfer switch must be protected by overcurrent devices, such as circuit breakers or fuses. These devices should be sized to protect the equipment from overload and short circuits. Wiring methods must also be considered. The wiring methods used for the generator and transfer switch must comply with the National Electrical Code. This includes using appropriate conductors, raceways, and connectors. Inspections and testing are also an important part of the installation process. The installation should be inspected by a qualified electrical inspector to ensure that it complies with all applicable codes and regulations. The system should also be tested to ensure that it functions properly. Proper maintenance is also very important after the installation. The standby generator should be maintained in accordance with the manufacturer's recommendations. This includes regularly inspecting the generator, changing the oil and filters, and testing the system. Permits are required for most standby generator installations. It's important to obtain the necessary permits from the local authority having jurisdiction before starting the installation. Safety precautions are very important when working with electrical systems. Always to energize the circuit before working on any electrical equipment. Wear appropriate personal protective equipment, such as gloves and safety glasses. Follow all safety procedures and guidelines. The National Electrical Code Article 701 covers legally required standby systems. Article 702 covers optional standby systems. Article 700 covers emergency systems. Ensure compliance with the relevant article based on the type of system being installed. The location of the generator should comply with local codes and regulations. Consider factors such as noise levels, exhaust fumes, and proximity to structures. Proper ventilation is crucial for generators to prevent overheating. Ensure adequate airflow around the generator to dissipate heat. Fuel storage requirements vary depending on the type of fuel used, such as gasoline, propane, or natural gas. Comply with local regulations for fuel storage and handling. Automatic transfer switches are designed to seamlessly switch between the utility power and generator power. Select an ATS that is compatible with the generator and meets the load requirement. Transfer switches can be either manual or automatic. Automatic transfer switches provide a more seamless transition between power sources. Surge protection is important to protect sensitive electronic equipment from voltage spikes. Install surge protective devices at the service entrance and at the generator output. Remote monitoring systems allow users to monitor the generator's performance remotely. These systems can provide alerts for low fuel levels, maintenance requirements, and other issues. Consider the environmental impact of the generator installation. Choose a generator that is energy efficient and minimizes emissions. Some jurisdictions offer incentives for installing energy-efficient generators. Properly size the generator to meet the load requirements without oversizing it. An oversized generator can be less efficient and more costly to operate. Conduct regular load testing to ensure that the generator can handle the intended load. Load testing involves running the generator under full load to verify its performance. Noise reduction measures can help minimize the noise generated by the generator. Consider using sound enclosures or mufflers to reduce noise levels. Proper grounding is essential for the safety and performance of the generator system. Grounding helps to prevent electrical shock and ensures that the generator operates correctly. Comply with all applicable codes and standards for grounding. Conduct regular inspections of the generator system to identify any potential problems. Inspections should include checking for leaks, corrosion, and loose connections. Maintain accurate records of all maintenance and repairs performed on the generator system. These records can be helpful for troubleshooting problems and ensuring that the system is properly maintained. Train personnel on the proper operation and maintenance of the generator system. Training should cover safety procedures, troubleshooting, and routine maintenance tasks. Keep the generator area clean and free of debris. A clean environment helps to prevent fires and other hazards. Consider the security of the generator system. Protect the generator from vandalism and theft. Install security measures such as fencing, lighting, and alarms. The National Fire Protection Association, or NFPA, provides standards and guidelines for generator installation. Consult NFPA 110 for emergency and standby power systems. Ensure that the generator system is compatible with other electrical equipment in the building. Compatibility issues can cause problems such as voltage fluctuations and power outages. Use high-quality components and materials for the generator installation. High-quality components are more reliable and durable. Properly label all components of the generator system. Labeling helps to identify components and ensures that they are properly maintained. Consider the future needs of the building when designing the generator system. Plan for future expansion and load growth. The generator system should be designed to accommodate future needs. The installation of a non-SDS optional standby generator involves careful planning, execution, and adherence to safety standards. By following these guidelines and working with qualified professionals, a reliable and safe standby power system can be achieved. Ensure compliance with all local codes and regulations. Local codes and regulations may vary and could affect the installation requirements. Obtain all necessary permits before starting the installation. Permits are required for most generator installations and help ensure compliance with local codes. Plan for regular maintenance to ensure the generator operates reliably when needed. Regular maintenance includes oil changes, filter replacements, and inspections. Consider the environmental impact of the generator installation. Choose a generator that is energy efficient and minimizes emissions. Provide adequate ventilation for the generator to prevent overheating. Overheating can damage the generator and reduce its lifespan. Follow the manufacturer's instructions for installation, operation, and maintenance. The manufacturer's instructions provide specific guidance for the generator model being installed. Use qualified electricians and technicians for installation and maintenance. Qualified professionals have the knowledge and experience to ensure a safe and reliable installation. Test the generator regularly to ensure it functions properly. Regular testing helps identify any potential problems before they become major issues. Keep detailed records of all maintenance and repairs performed on the generator. Detailed records can help track the generator's performance and identify trends. Train personnel on the proper operation and maintenance of the generator. Trained personnel can operate the generator safely and perform routine maintenance tasks. The transfer switch must be compatible with the generator and the electrical system. The transfer switch ensures a seamless transition between utility power and generator power. Consider the location of the generator to minimize noise and disruption. The generator should be located in an area that minimizes noise and disruption to neighbors. Implement safety measures to prevent accidents and injuries. Safety measures include proper grounding, ventilation, and fire suppression systems. Properly size the generator to meet the load requirements of the building. An undersized generator may not be able to handle the load, while an oversized generator may be less efficient. Consider the fuel source for the generator and ensure a reliable supply. Fuel sources include natural gas, propane, and diesel. Install surge protection to protect sensitive electronic equipment from voltage spikes. Surge protection helps prevent damage to electronic equipment during power outages. Consider using our remote monitoring system to track the generator's performance. Remote monitoring systems can provide alerts for low fuel levels, maintenance needs, and other issues. Plan for emergency situations and develop a response plan. An emergency response plan can help ensure a coordinated response during a power outage. The grounded conductor must be properly sized according to the National Electrical Code. Proper sizing of the grounded conductor helps prevent voltage drops and ensures the generator operates safely. Use appropriately sized conduit and wiring for the generator installation. Proper conduit and wiring helps prevent overheating and ensures the generator operates safely. Use approved fittings and connectors for the generator installation. Approved fittings and connectors ensure a secure and reliable connection. Grounding electrode conductors must be properly sized and installed. Proper grounding electrode conductors help protect against electrical shock and ensure the generator operates safely. The grounding electrode system must meet the requirements of the National Electrical Code. A properly installed grounding electrode system helps protect against electrical shock and ensures the generator operates safely. The generator must be properly labeled with all required information. Proper labeling helps identify the generator and ensures it is operated safely. All electrical connections must be tight and secure. Loose connections can cause overheating and electrical hazards. Conduct a thorough inspection of the generator installation before energizing the system. A thorough inspection helps identify any potential problems before they become major issues. Use appropriate personal protective equipment when working on the generator. Personal protective equipment helps prevent injuries and electrical shock. The generator must be installed in accordance with all applicable codes and regulations. Compliance with codes and regulations ensures a safe and reliable installation. The generator must be tested under load to verify its performance. Load testing verifies the generator can handle the load requirements of the building. The generator must be properly maintained to ensure its reliability. Regular maintenance helps extend the life of the generator and ensures it operates safely. The generator must be operated in accordance with the manufacturer's instructions. Following the manufacturer's instructions ensures safe and reliable operation. The generator must be protected from the elements. Protection from the elements helps prevent corrosion and damage to the generator. The generator must be installed in a location that is accessible for maintenance. Accessibility makes it easier to perform routine maintenance tasks. The generator must be installed in a location that is well ventilated. Adequate ventilation helps prevent overheating and ensures the generator operates efficiently. The generator must be installed on a level surface. A level surface helps prevent vibration and ensures the generator operates smoothly. The generator must be secured to prevent movement. Securing the generator helps prevent damage and ensures it operates safely. The generator must be installed in a location that is free from obstructions. A clear area around the generator ensures adequate ventilation and accessibility. The generator must be installed in a location that is not subject to flooding. Protection from flooding helps prevent damage to the generator. The generator must be installed in a location that is not subject to excessive dust or dirt. Protection from dust and dirt helps prevent damage to the generator. A generator must be installed in a location that is not subject to extreme temperatures. Protection from extreme temperatures helps ensure the generator operates efficiently. Consider the noise level of the generator when selecting a location. Select a location that minimizes noise and disruption to neighbors. Consider the environmental impact of the generator when selecting a location. Select a location that minimizes the environmental impact of the generator. Consider the aesthetics of the generator when selecting a location. Select a location that minimizes the visual impact of the generator. The installation of a standby generator requires careful planning, execution, and adherence to safety standards. By following these guidelines and working with qualified professionals, a reliable and safe standby power system can be achieved.